with the properties of our logarithms and our exponentials helps us today when we're looking at solving these equations with logarithms and exponentials. Same properties we did before we'll be utilizing here, in particular with our one-to-one property. When we had the one-to-one property with our exponentials, right, when we have the same base, a to the x equals a to the y, what does this mean? Absolutely. So if I already know I have that same base, I'm just going to look at setting those exponents equal to 1 another. Likewise, we had that one-to-one property with our logs. And we had that log base a of x equaling log base a of y. So when they have the same base, what does that mean? Same thing. So if I can get the same bases, whether I'm talking about a logarithm or exponential, we just automatically have our answer, x equals y. So here I have 2 to the x equals 32. So can I use my one-to-one property as it is right now?
No.
What do I need to do?
Make the bases.
Absolutely. So I want to turn that 2 to the x into 32 to something, right?
No, 2 to something.
Right. I'm going to go ahead and take that 32, get that same base as the left side, so 2 to the x equals 2 to the 2, 4, 8, 16, 32. Right. So we can rewrite that 32 as you guys are showing me as 2 to the 5th. I have the same base, so this tells me x equals 5. So I said this is very exciting stuff. So what about natural log of x minus natural log of 3 equals 0? Is it set up to use 1 to 1? As I was saying, let's move the natural log of 3 to the other side. So now we have that log base a of x equaling log base a of y. In this case, what is my base? E. So in this case, since they do have the same base, it is just x equals 3. And lastly, that 1 over 3 raised to the x power equaling 9. Guessing you know I have the same base. What base would I look to try to do here? Absolutely. So how do I rewrite my 1/3 as 3? 1/3 is 3 to the negative 1, moving the 3 up to the top. As I already said, with the x up there, 3 to the negative x, and 9 is just what? So I have the same base, I just add negative x equals 2, or once again, just using the one-to-one property. Sometimes that's the easiest thing to do for solving our equations. We can also use inverse property. The inverse property, you guys remember, we had a raised to the log base a of x giving us. So now there's all this pretty much just disappears, right, when I have the same basis. And log base a of a to the x also equals x. Did you see this somewhere recently? About at least 3 or 4 times. Here you were just using, when these two were the same, all this stuff just canceled out more or less. Because log base a of a to the x, don't forget what that means is what power do I raise a to get a? That's the power of 1. So that just becomes that 1. So here we want to solve for x. Can I use my one-to-one property? Natural log of e to the x equals natural log of 7. Can I use the one-to-one property?
Yes.
Yes. I think it's one-to-one property. One-to-one property says that they have the same base, right? What would I get with the one-to-one property though?
You like to do something.
E to the x equals 7. That doesn't really get us too much closer to solving for x. But what can we do? The inverse property, what do I know?
Doesn't it cancel from you?
So if we said this is just natural log of e this cancels out. Because that natural log of e, what is that? Absolutely. Okay, so if we said that natural log is log base e, but we don't write down log base e, we write down natural log. So when you see that natural log paired up with the e, you know that's us pretty much canceling out, and I'm left with just the s. Likewise here, we have e to the natural log of x equals 4.5. What happens? Sorry? Because again, just like right over here, instead of having a's, I have my e's. But again, we don't write down log e, we write down natural log. So in this case, we come up with x equals 4.5. And lastly, 10 to the log of x becoming 10 to the negative 1. Why? Why is the left side x? Absolutely, it's understood. This is our common log, which has a understood base of 10. So with inverse property, all that's done, we just have x equals 10. So these are the properties, our inverse properties and our one-to-one property, what we use to solve our exponential and log equations. Step by step, again, strategies for solving the exponential. Easiest thing to do, if you can, put it in a situation where we use our one-to-one property. So we have this 1 over 4 to the x equaling 16 squared. Well, we can't use our one-to-one property right now, can we? Mara said we need to get that same base. We're going to look for the base of 52, right? 4? Okay. I thought I wanted to use it. It's actually 42. So, Mara said use the base of 4. Okay, so how do I write that left side with a base of 4? Okay, then again, 4 to the... Absolutely. To bring the 4 to the top, right? Negative exponent. What about the right side? Absolutely. 16 is just 4 squared. It has that same base. 4 squared squared is... So now I have 4 to the negative x equals 4 to the 4th, or just... Absolutely. Complicated stuff, right? So, can't use that one-to-one property. Can sometimes use the inverse property, which is just happens by taking the logarithm of both sides. Taking the logarithm of both sides is pretty much the same thing as taking your exponential and writing it in log form. That's all we're doing here. So, here we have, for example, e to the x equals 15. If we wanted to, could we use one-to-one property? If you can somehow write 15 as e to some power, sure. So what are you saying, Mario?
I just said it's more 15. But I don't know why you call them.
Two things. First of all I have to do is take the logarithm, start off with just using the inverse property. So if I take the log of both sides, what I want to do is cancel out everything except for that x. So I want to cancel out the e. So what base do I want to use for the log I take of both sides?
Base E.
Base e. So if I take the log base e, or just my natural log, again, what I do to one side, I must do to the other side. What's going on with the left side? Natural log of e goes away, and I just have x equals natural log of 15. If I gave you this, e to the x equals 15, what form is it in? It's in exponential form. If I say rewrite it in log form, what would we do? That's exactly what we just did. We just wrote it in log form. So by using the inverse property, taking log of both sides, in actuality what we're doing is we're just writing it in log form.
What's the first one called?
Doing this is using the inverse property. So using the inverse property by taking the log of both sides, there is no, doesn't have a name.
Like the e to the x equals 15%.
Oh, exponential form. This is our exponential form, e to the x equals 15, and x equals natural log of 15 is our logarithm form. So here, we want to go ahead and solve, round to 3 decimal places if necessary. John, any ideas? How to solve this first one?
Just kind of said the exponent equals 0.
So I'm using the,
That would give you 1/4.
absolutely, as John said, we're using the 1-1 property here. I'm just setting the exponents equal. Well, I set it equal to 0. And then we see we have an impossible factorization that has complex 0, so we might as well use the quadratic formula. No?
I raise things.
Actually, so here we come up with x equals a -3 or x equals -2. You can go back, plug in those answers to see if it works. In both cases, it does. If you have the time, folks, check your answers. See if when you plug it back in, if it makes sense. During the times you have the time. I know maps are very important to us. SOAR grades, right? So it's not about who can finish the test or the quiz the fastest, but most accurate, right? So, what about this one? 4 times 3 to the x equals 64. Can I use my one-to-oneness here?
No.
What do I want to start off doing?
Is the form that like the power thing?
No.
You could factor out a 4 from 64.
In algebra, how did you go about solving an equation, solving for x? The whole thing was to do what?
Get exponents.
What's that?
Get exponents, so.
Isolate x, get x by itself. So what do I want to do here? I want to get x by itself. Well, divide both sides by 4, absolutely. I want to get that 3 to the x by itself. So I need this 4 away. So now I have 3 to the x equals 16. All right. Now what?
Well, you put it in log form, so 1 base 3 of 64.
So, 2 different ways. Again, first way, if we wanted to use the inverse property and take the log of both sides, what base would I use? Base 3, right? Because I want the 3's to cancel so that the x appears. So if I do the log base 3 of both sides, what happens to the left side?
Cancel.
Absolutely. As Habib said though, here is my equation in exponential form, and if I just said write it in log form, we would say log base 3 of 16 equals x. Again, that's all we're doing here. We're just writing it in log form. Are we done? Because it said in 3 decimal places, right? So here we're going to plug in 2 point what?
524.
524. Anybody get something different? Yes, sir.
Where do you get base 3 from when you take the log of both sides?
Where do we get the base 3 from? How did I know to choose log base 3?
Because
It's whatever the base is of our exponential. Because we want the 3's to match up where they will cancel each other out. So if I had 2 to the x equals something, I'd want log base 2. So, what about this one? 5 minus 3 e to the x equaling 2. So I get x by itself. So how are you going to do that? Sorry? Subtract 5. Divide by the negative 3.
divide by negative 3.
What now? We already divided by negative 3. What's that? Right. The natural log. Absolutely. So again, I can either our log base e or natural log. If I do that to both sides, what happens to the natural log in e? And again, this is going from, we're just doing one extra step, whereas if I just said write it in log form, right? Writing this exponential e to the x equaling 1 in log form is, again, starting off with the same base. Log base e going across equality of 1 equaling x. So here I get x equals the natural log of 1, or x equals 0. Yes.
If we, on, say, like a test or quiz, saw that e to the x equals 1, and anything that equals 1 that is an exponent has to have the exponent of 0, and just went straight to the answer, would that be acceptable, or would you like to see the work?
At least write it in log form.
Okay.
No, you don't have to do this. What about the next one here?
Minus
What's that? How does that have to divide by 6? So now here, let's go straight to doing what? Can I write this in log form? Okay, what do I get with it? Absolutely, just as Michael said, starting off with the base at log base 2 of absolutely.
you don't have to do log of addition.
All we're doing here is I'm skipping this step right here, and I'm just going straight from writing it in logarithm form. Okay, if I was to go ahead, let's take a look at it. If I was to go ahead and take the log of both sides, which base would I use? So I'd have my log.
Oh.
What happens to the left side? I'm sorry? Let me just get. Which is what I had previously. So again, they're the same thing, but doing it this way, you're doing one extra step. It doesn't matter which way you do it, as long as you get there, right? So now what? So plugging all this into our calculator. Giving us a negative 4.778. Questions? So now solving those exponentials. Solving a logarithmic equation, pretty much the same thing using our one-to-one or inverse properties. So starting off, and you write it so that it is set up to use the one-to-one property. Getting the same logarithm, right? Same base. So a really difficult one like this one, natural log of 5 minus natural log of x equals 0. What do I need to do to set it up for using my one-to-one property? Add natural log of x. If that doesn't work, you can go ahead and try using, like we did before, the inverse property by raising or exponentiating, raising both sides to a power of the base a. This is the same thing as doing what? Taking my log form and writing it in exponential form. So as long as you know how to go back and forth between the log form and exponential form, there is really no inverse method that you have to look at. So over here we have log base 3 of x equals negative 2. Let's first raise both sides to the power, and then we'll take a look at writing it in exponential. So what power would I want to raise it to? I want to have something raised to the power of log 3 at x. So where's that base I want to use? Michael? Michael? I want to raise everything. I want to use my base. So 3 raised to the log base 3 of x. So what is 3 log base? What happens with the 3 raised to log base 3 of x?
Cancel.
X equals what if I just said write this in exponential form? Same thing. I'm going to go straight from here to here. Right? Writing in exponential form, we will start off with the base. So we'd say starting off with 3 raised to the negative 2 equals x. Do you have to do this step here at all? No. This is just another, for some people this may be an easier method, so not being able to visualize going from the exponential to the log form. But that's all we're doing here. All right? So, natural log of x equals 2/3. What should I do here?
E should be. E to 2/3.
Mine is log base.
As Shonda said, e to the 2/3 equals x. Because what is the natural log?
Log C.
Sean said. It's just log base e of x to the 2/3. So if I write this exponentially, e raised to the 2/3 power equals x. Right? Or if you wanted to, again, you can raise e, raise every way to the e power, right? E raised to the natural log of x equals e to the 2/3. You can come up with the same thing. In this case, you get x equals yeah, 1.948. What about this one?
You just said it equal to something. As the base is missing.
Absolutely. Since I have the same base as I said, this just becomes a 1-to-1 property. No. Something that you must do when you're solving a log equation. You don't have to worry about exponential. What is the domain of an exponential equation, function? Negative infinity to positive infinity, all real numbers. What is the domain of my logarithm? 0 to infinity. When we come up with these answers, in particular when we're using quadratics and stuff like that, we always must check our answers to make sure that it fits in that domain. So, here we have x equals 1. Do we have any issues? No. When I stick in x equals 1 over here, 3 times 1, 3, plus 2 is 5. Over here, the same thing. We get 6 minus 1 is 5. It works perfectly fine. Actually, all the ones we're doing today work out fine. Unfortunately, some of your homework ones do not. So always check your answer. Does it fit in the domain? Only when you deal with logs. When you deal with exponentials, of course, it's always going to fit in the domain.
What's your answer?
No answer, no solution. If it doesn't work right, there is no solution. What about this one? Can I use my 1-to-1 property? As it stands, no. 1-to-1 property only works with 2 logarithms. A log on the left and a log on the right. Absolutely. I heard condensing and I heard using the quotient property. Absolutely. So here we have our log base 3. We're using the quotient property, condensing, or perhaps I may be using the product property, but in this case, since we had the minus, all right, we're using our quotient property, giving us just 2 logarithms now, log base 3 of 5x plus 13 over 6 equals log base 3 of 3x. So now what? Absolutely. Logs disappear. Just now we just had that 1-to-1 property. Multiply by 6. X equals 1. And we take a look at that. Sure enough, when we plug in x equals 1, it doesn't give us a negative log anywhere. So this solution works fine. Solving these. 6 plus 3 times the natural log of x equals 4. Cool. What should we do starting off? Okay, we want to isolate x, so first what we do, Subtract the 6, all right. So I get 3 times the natural log of x equals negative 2. You fine. So dividing by 3, I get the natural log of x equals negative 2/3. Now I can do one of two things, right? I can take e, raise everybody using e, or I can go straight to, or do everything raised to the e. Disappears. But that's the same thing, once again, it's just writing it in exponential form, right? Taking the log form, writing in exponential form, I get x equals either the negative 2/3 or x equals 0.543. Yes, no? And 3 times log base 4 of 6x equals 9. And then we take the square root of both sides and then subtract 42. That's the back way of doing it, right? And come up with the answer of 7. Yes?
Yeah.
Unfortunately, I'm taking this one and people are probably writing this down. So,
Divide by 3.
absolutely, I want to isolate, so here we're going to divide by 3. And now what? As Joe said, writing it in exponential form. I can write this in exponential form. 4 to the 3rd equals 6x. What is 4 to the 3rd? Yeah, you don't need to calculate for this. What's this? Yeah. 3 goes into 32 10 times, so you have a remainder of 2. 2/3 is what? 6. I've probably been doing that for a little bit longer than you. So let's see. So, questions on this? Let's take a look at some applications here. So, same stuff we had before, dealing with our exponential rate of decay and our compound interest. So here we have deposited 1,000 in an account that pays 6.25% interest, compounded continuously. What formula are we using here? Sorry? What information do I have? Right. I have my what?
I mean,
And P. What is R? In this case. Do I know what A is?
no.
Actually, I do.
I don't think that,
For this particular problem, could we have solved it if I did that? Yes.
Yeah.
Michael? If I did not tell you how much we started off with, would that change the way we did this problem?
teachers make
Because what would my A be? Sophie? As Sophie said, my A would just be 2P. So instead of having 2,000, is 2p. So in this case, I'd have 2p equals, again, if we don't know what p is, it's p, e to the, what would I do now? So first thing I want to do is, so doing what? Divide by p, giving me so p doesn't matter what it is, whether it's $1,000, $5,000, $100. It says I want to find out when I double the amount, when I triple the amount, or anything like that. Do not be thrown off if they do not give you that amount of money, because you can just do it like this. As you can see, that initial amount principal is irrelevant. So what do we do now?
Convert it to log form.
Convert it to log form, okay. Or again, convert it to log form, or just take the natural log of both sides, whichever you're more comfortable with. If I take the natural log, I'm going to wind up with the log form. Right? Divide by the rate.
.090.
Can you go up like a step? Because I'm confused on how you went from, like, why'd you get rid of the L and the sleep on the second part?
That's what we did when you were out in the halls.
Okay. Oh, yes.
So what do we get? It's not too bad for doubling your money. 11.1 years, you're sitting in your account.
So for like years, we only have to go to one decimal place?
Again, I will, on the quiz test, I'll tell you how many, but good rule of thumb, especially if you're talking about years or months or something like that, saying 11.237 days or years, it really doesn't make a lot of sense. So. What about this one? I'll let you guys try this. Tell me what you get. Make sure you read it and understand it before solving. So, what is that 342 in this problem? I'm sorry? My A. There's no A.
That's what you're looking for.
Here's the formula I've been given, right? Which will find the number of endangered species. Where my T is just the years, right? So, 300. We want to find what year will it reach 342 endangered species. So what am I substituting in with that 342? That's replacing my Y. So now, again, just like we've been doing, we're going to isolate our variable. So starting off with add 117. Giving us 459 equals 159 natural log of t. Divide by 159. Absolutely. Write it in exponential form. Again, my natural log is log base e, so that's just e to the e to the 459 divided by 159, or t is equal to. Okay. So you said about what, Michael? 18 years. Is that my answer? Absolutely. Make sure you read what they've asked you to find. They didn't ask us to find how many years. They said in what year. During which year will they reach 342? So since t equals 18, and we already know from here that t equals 10 corresponds to the year 1990. So t equals 18 is 8 years later, 1998. Question? As we did on some of these, or as I said before, don't forget when you're doing like 76 through 100, to check your answer. When you're doing the log equations, does my x fit in that domain? Right?